All right, so right now we're going to take a look at collections, proxies, and show that I've got a manager here for my game sprites. So um, we take a look here at, or the game objects rather. So we've got these game objects, they've got a manager, it's already starting to work on um, a collision system using an observer and a visitor pattern. And um, yeah, so let's take a look at what it looks like right now. Now I do have a test in to remove and resurrect all of the game objects that are in the grid. Well, it's actually working on the sprite batches um, rather than the game objects at the moment, although those are going to be integrated. You can sort of see how it reverses directions due to the way that the graveyard that I have working now works. Instead of having a two list system within the managers, I've introduced a third list. So now we have a list of active um, objects, a list of reserve objects that functions as a memory pool, and a list that I've called graveyard, which if you think of it in terms of a card game, you have your hand, you've got a deck that you're drawing from, as well as a discard pile. The discard pile here is my graveyard, and the graveyard can simply be turned back on using this resurrection. Although I've got some kinks to work out, as you may be able to tell from this here. So I'm going to turn that off real quick so that we can just take a look at this again. Now, what's going on here is that there is a grid that is being updated that moves the aliens, pushes that information to the game objects that represent them, and um, then they push that information to their proxies. So, still got the timer manager pushing updates. Which changes the animation and triggers the grid movement, but that just pushes that information to the game objects. Now the game object manager update, which we're going to look at real quick, actually goes ahead and get the active head and walks through all of the um, game objects and updates them. So when they're updated, it pushes to the proxy sprite, um, the X and the Y for their new location, and so that just does that. We're going to go ahead and step back out. From there, we've got the sprite batch manager doing a render down in our draw section, and so what we find is that the render actually is going to render a so it targets, it's got its target. That target is actually a proxy, and so that proxy pushes to the game sprite itself that new data, updates the game sprite, and then renders the game sprite. And So in that way, I've actually only got, in terms of what's on screen, three game sprites. I also have a null, and that's in the manager, but that's not rendering. So that way we see that it updates the sprite, it renders, and then it's going to display that sprite at well, there's no real good way to show this, at that location, or at a particular location. Then when we render the next sprite, it will um, actually, even if it's targeting the same game sprite, it will again update that information in terms of the location that we're pushing to the actual game sprite. And using that information, it will again draw the same game sprite on the screen at a new location. So that rather than having the 55 game sprites that would be required to draw a grid of 55, since we only have those few aliens, those three aliens drawing on the screen, types rather, we only see, or we only actually are using three game sprites despite there being so many. Now they're all arranged in a grid, which I discussed, or I pointed at in my last video. That grid is sort of a modified version of the composite pattern, where instead of drawing a direct composite pattern, what we've got going on is a parent-child sibling tree. So it's kind of an unbound tree, but not exactly. Um, it's not entirely dissimilar from a rose tree, or it could be considered a variant on that, where each node um, can have a sibling, a parent, and a child. So, but it can only have one child. But that child can have a lot of siblings. And so what we see here is that, each of these aliens, can I pause this and still show it? Not really. Yeah. So each of these aliens is inserted in a grid. So we have these 11 columns, and in each column, the grid that's they're in is their parent, or is the parent of each of these top rows. This is a sibling to this, this is a sibling to this, this is a sibling to this, and so on and so forth. Whereas this straight up and down is a parent-child relationship, which is sort of a so what we end up with is a base node that serves to hold a singly linked list of a doubly linked lists. That's in terms of drawing just a grid, going to be preferable to the composite pattern, as it's easier to sort of envision the structure that you're creating in that way, and simplifies the process of getting early outs in terms of the um, when an alien undergoes a collision. Um, and yeah, so the proxy sprites are small and are what is being drawn now by the or is what the those are actually going into the sprite batch manager rather than game sprites, because they can control and stand in for um, the game sprites. The game objects all have proxies that they point at, and those proxies, which are of the same type as the game sprites, which is like a base sprite class, um, go ahead and point at the game sprites themselves. So if we wanted to see the, well, this wasn't what I meant to bring up, but it'll work. I was going to show you a class diagram, but we can see that these are the used types here. Um, uh, so we've got the game sprite, so the proxy aggregates game sprites and is used by game objects, um, which aggregate the proxy sprites. And the game object still has a pointer here to the game sprite in order to um, tell the proxy sprite which game sprite it's referring to, but that's just simply a pointer, and it gets that through the game sprite manager. Yeah. I also have an iterator for the um, PCS tree. I guess we can go look at that real quick. So it inherits from a general iterator, an abstract iterator that I've created. Um, any node in the PCS tree can generate an iterator, and then that from that point, the sort of subtree can be analyzed. So that way, if a column is indicated as being hit, we can just grab an iterator on that column rather than iterating over the entire tree, which is maybe silly. I'm not quite sure yet. It also initially finds the lowest direct descendant child, so it's the it finds all of the children and goes down and down and down. And then if the lowest child has siblings, it goes and tries to find the closest sibling with children, and then goes down and down, and then siblings there, children, and so on and so forth. Um, and that way it can walk back up. It's got some reference pointers to keep track of where things are, and the terminal condition is when the node that generated the iterator is visited again. So that's how the has next works. If if there's no more siblings and the parent is not the head node, then it has the next. Otherwise, you're done. Because that means that actually that might be a problem there. Anyway, yeah. So, but the iterator is being used in the management of that resurrection function that we looked at, and so it works. But I actually am just now realizing that I think it only will work on the if you take the grid, or it won't address the initial node, or that as a final point in its iteration, because it is sort of a reverse iterator. But since I'm only ever going to be taking it from a column or a grid, that's going to work. Although I should probably document that. Yeah, that's why it works that way, because that was the idea. All right. So that does it.